Thank you for attending today's webinar of adesso, Bulgaria. The webinar is with the topic automatic visual inspection in manufacturing. And we will talk about automatic visual inspection, what it is, why it may be the right and necessary next step in the successful development of companies in the manufacturing sector. And of course, adesso Bulgaria will present the way of automatic visual inspection, how it works, and elaborate on how it could optimize the defect recognition process at large production facilities. Before we start, I would ask everybody to mute themselves and preferably to switch off their camera for a better connection. If you have any questions during the presentation, please ask them in the chat. And afterwards, we'll have a discussion round where you can also ask your questions to the speaker. So now I will give the word to Mr. Jordan Bozogiev, a software developer at adesso Bulgaria, to present the topic. Thank you.
Hi everyone, and thanks for participating in this presentation. I hope that it will be an interesting one for you. And yeah, let's start with the presentation. As Ljubljana said, it is about automatic visual inspection in manufacturing. So today's presentation will be led by me, Jordan Bozogiev, and also my colleagues, Jordan Terziev and Snezhina Popova. So if you have any question during this presentation, don't hesitate to stop us and ask your question. So first, I'll give you some more information about adesso Group. Then I'll make a brief introduction about automatic visual inspection and how you can benefit from it. And we will end this presentation with some success stories of manufacturers who have already implemented automatic visual inspection for their business. So adesso Group is one of the leading IT providers in a German-speaking market, providing both IT consultancy and customized software development. With more than 5,000 people, employees around different countries in whole Europe, we have the experience that make us a reliable partner for your IT projects. Adesso combines technology competence with sector-specific know-how, and our work is based on proven methods while implementing software projects. But let's get back to the main topic of this presentation, and it is actually about automatic visual inspection and why you should care. The quality control inspection is a task that strongly depends on human visual understanding and adaptation. Inspections in industrial setup can be very risky, tedious, costly, and time-consuming. And sometimes it is nearly impossible for the humans to detect some defects on the machines manually. During the visual quality control process in manufacturing industry, human errors tend to occur in range from 20 to 30%. And I think this is a very big number, so it is a common problem for the manufacturers. So how can we actually solve this problem? Nowadays, with the evolution of machine learning and computer vision, we have the power to implement automatic visual inspection for the quality management. And it can actually reinvent the process of routine human inspection. The end-to-end programmed automatic visual inspection can significantly reduce the risk of poor quality inspection, and it can also lead to reduced manufacturing costs over time. But what are the main methods of the automatic visual inspection, what technologies stand behind that. That's what I want to present you right now. And the first method is the so-called object detection. And with the object detection, the computer can actually analyze and understand images. That means when we give a picture to the computer, with the help of this method, it will be able to detect if there is any object on the image, for example, and also localize it where it is on the image. And in this example, we have a picture of an impeller. So it is actually this part here. This is a part of a pump or compressor that rotates at very high speed. And when we give this, this image to the computer with the help of the object detection, it will successfully tell us that this is an impeller. And in this exact example with this picture, our model is sure with 99.7% that this is an impeller. And we cannot do object detection only on images, but we can do it actually on videos and even in real time. And that's what I want to show you right now. So we've prepared a small demo with application. It's a web-based application where we use TensorFlow and one model which is very popular. It's called MobileNet, and it can actually detect about 80 different classes of objects. So when you click here, start detection, now with the help of our web camera and this application, the computer will be able to know what is front of the camera. So now we see I'm here in front of the camera and it sees me. It says this is a person, and we also see this accuracy. So that means it is 94% sure. And I have also some items near me, which we can try if the model can detect them. So if I go with my cup of coffee here, it will again detect the cup. It will localize it. If we go like this, it knows where exactly it stays on the video. So here is a remote controller. Again, it knows that this is a remote controller. My cell phone. And also here is a bottle. So these are about 5 different objects that the model can detect, and actually there are more than only these 5 objects, but this just for the example right now. So yeah, the model is well trained, and it can detect the objects pretty well and localize where they are on the image. And we cannot do only object detection, but we can actually do the other main methods of the automatic visual inspection, the so-called defect detection. So with defect detection, we can actually detect some object, and we can do a quality inspection of that object. That means we can detect if the object is with good quality, if there are any problems, if there are any defect on the project on the object. And when we imagine that we have a process line in our manufacturing, With the real-time inline inspection can then automatically distinguish faulty products at speed and allow time for a corrective action to be taken. And this is very helpful for dynamic environments where things are changing and precious time can be saved and dedicated to other tasks. And this also will help us, will help the manufacturers to stay in compliance with regulatory requirements. And we have another small demo, which is again a web-based application where we have a model which was trained on these images, which we already saw. They were on parts, and the model was trained on different images. Some of them were defective parts, other not. And now here we have some test data. So these images, the model has never seen before. And for example, if we give now this image to our model, we upload it, and our model will now tell us that this is a defective part, and we can surely see that there are some defects on this part. So the guess is actually a valid one. And if we try with another one, this one here looks like there are no defective parts on it, and our model will say that it is a not defective one. So this was an example of how we can use automatic visual inspection, the machine learning to do a model, to create a model which will then which can say if any part is defect or non-defect. But why is computer vision inspection actually better than the manual inspection? And in fact, there are a number of advantages for computer vision in comparison to the manual inspection. And here we've listed some of them. So the automatic visual inspection has a higher optical resolution, and that means it can spot some features of the image that the human eye might not be able to see. This means the model, the machine vision can detect some details of the image that are very small and inspect them with greater reliability. And this technology can also analyze complex surface and cosmetic defects like dents or scratches on parts that are turned, brushed, or shiny. The other thing is that the human eye is incapable of making precise calculations, precise measurements, especially especially on very tiny scale. Even when we compare two same objects, the eye might not notice that the one is slightly smaller or bigger than the other. And this concept also applies for characteristics such as surface roughness, size, and any other factor that can be measured. And with the help of machine vision, we can actually detect an object. We can and we can do some measurements of we can get information about the measurements of the object instantly. And compared to the human side, the machine vision has a wider spectrum of optical visual perception, and it is able to perform observations even in X-ray, ultraviolet, and infrared regions of the spectrum as well. The other thing that is a plus for the machine vision is that the very fast and precise calculations. And today, the computers are becoming faster and faster. And with this computing power, we can do very fast and precise calculations. So if we again imagine that we are in our manufacturing and the process line, then with the machine vision, we can scan the product and we can get instantly information about the size and yeah, everything that we want to actually calculate. And the automatic visual inspection doesn't need any break, so it can work 24/7 without any break. And most importantly, this way we can focus human resources on other tasks that are important for the business and make the whole process more effective. And the last point is about absolute memory. And what I mean here, to ensure delivery of high quality products, the people who are responsible for the inspection of these products, they have to be experts in the domain. And that means that they have to learn to be such experts. Significant training is required, and sometimes they cannot process all the information because of the limitation of human brain, and this could lead to inspection errors. And on the other hand, we have machine vision, where models are trained on hundreds of thousands of images. So now it might be even possible for the models to be better experts in the domain because they have seen so many different examples. They can see also examples that the human has never seen before, and now they are aware of defects that the expert hasn't seen. Another plus is that this model will continue with the learning process on everyday workflow. So every day the model will become better and better in inspecting, for example, if the product is defect or non-defect. And here on this slide, we have two optical illusions that are examples that can demonstrate how unreliable our eyes are. So on the left side, we see parallel lines which appear to be sloping. So I hope that I'm not the only one that sees them sloping. And on the right side, we have some black dots that appears on and disappears on the intersection of the light lines. So these are, I found these examples as cool because they can demonstrate how unreliable our eyes are. And if you are still not sure if you can benefit from implementing automatic visual inspection for a business, here we've provided a small survey which will answer some of the most common questions that you might have. And if you still need some more detailed consultation, then feel free to send us an email. We will be very happy to answer all of your questions. This survey here we will send you per email. And yeah, now I won't go through these all questions. You can just go through them and answer for yourself. And yeah, if you want, then we can discuss how we can work together. And yeah, and sorry, as I said, we'll end this presentation with some success stories of companies who are already doing it. So the first one is from Fujitsu Laboratories. They implemented a system which ensures that the parts are with high quality. And this system was actually very successful, and then they decided to implement this system all across their company's production sites. And the other example is coming from Domino's. So everybody from us once has been not satisfied with their purchase maybe, and Domino's decided to create a pizza checker, which will then check if the pizza is the right one that the customer has purchased, or if the toppings are the correct one, and if they are evenly distributed. And actually, this pizza checker has scanned more than 30 million pizzas since they developed it. And the product quality scores has boosted with more than 15%. So it was a great success for them. So that was actually our presentation about automatic visual inspection. We didn't get into details about the technology. It is not a technical one. We want just to present you that there are such technologies and what you can do with them. So now that you're aware of them, you can start thinking of how this can actually help for your business. And yeah, actually machine learning, computer vision are fields which are getting better and better extremely fast. So there are no big limits. There are no limits there. So yeah, you can be creative, think of some ideas, and we will be very happy to discuss them together and find a solution together and work together. Yes, this was our presentation. So now if any of you have some questions, feel free to ask.
Thank you very much for the interesting presentation. I hope it was also interesting for our participants. As I wrote in the chat, please do not hesitate to ask your questions also live, to direct to Jordan or in the chat. So do we have someone who has a question? Okay, maybe until somebody decides to ask. You gave a great examples, 2 examples of implementing the systems. Do you have also examples with companies here in Bulgaria, like local ones using it?
I didn't research about companies in Bulgaria that use this kind of automatic visual inspection. Maybe if my colleagues know about some of companies, yeah, they can say. But I think that companies are starting to get in this field. They are starting to do researches and research how they can benefit from it. And yeah, in the next years, we will be definitely see some more examples. And I hope that we will see these examples in Bulgaria as well.
I think there's one example in Bulgaria. So Nestle, I think the chocolate producer, it was also in the news. They have invested heavily in automated visual inspection for their chocolate bars, so to say. And it was one of the interesting examples. I think there could be more also in Bulgaria, but that's the one I have in mind right now.
And Mr. Teziev, do you want to add something to the topic?
Well, we just wanted to introduce the topic, so very generally and very brief. And thank you, Jordan, for that presentation. And I think there's a lot of potential there. And what I would like is that we are prepared to experiment with possible applications and try it out. And it's kind of a new topic, not necessarily a new topic, but we look it through a new direction. So there have been such approaches, but using machine learning and cameras, like Jordan showed, we can detect what objects are there in front of the camera. You can achieve pretty much many things that nowadays are made by humans, and that would lead to a very large cost reduction, so to say. And like I said, it's a first presentation from us, so showing what is possible. I hope we could do that.
Yeah, of course.
Thank
I
you.
think it was very understandable, and it was also very interesting. I'm still waiting for questions from the audience. If they're not, if nobody wants to ask something, then it's good for us because everything was understandable and clear to everybody. We will send the presentation to the participants, and there is also a recording of the meeting, which we will upload in our YouTube channel, the channel of the chamber. So everybody who wants to watch the webinar again or further it to some clients, of course, they can do it. So I will give a last chance to other participants to join and add something to the discussion.
Yes, and
so it's Dimitar here. I have one question. Do you work only on the software solution, or you also work on the whole solution? For example, the whole process, if it needs some orientation of the parts or some kind of specific positioning. Do you offer the whole solution, or you only work on the software solution?
We could work on the whole solution, of course, with some partners, and this is a whole process, so to say. We don't offer a specific system because the system is very dependent on the specific case and on the parts that have to be checked.
Customizable.
It's very customizable, and there must be we have to collect training data from the existing process. So like Jordan showed, which parts are defects, what are defects, what are possible defects, and this is a whole process that need to be done in order to achieve a quality that is comparable with the human one. It depends on the situation of the specific situation currently. If you have some system in place, then it might be optimized. If you don't have any, then we can look at how much training data we need and what results we can achieve in what time, and that might be a first step in the direction, so that you get somewhat of a cost estimation, and then what would be the return on that investment. Yeah, we can.
Okay.
To answer it shortly, we can look at the whole process.
Nice, thank you.
Yeah. Thank you very much.
Thank you very much for the question. Do we have other questions now? Okay. Well, if this is so, maybe if Jordan doesn't want to add something to...
Yes, these slides, maybe some of your questions are like this one, and they're about if such such system needed for your business. So as I said, we will provide you this, and yeah, we will be very happy to have a more detailed consultation if you need.
Okay, thank you very much. So as he said, we will send you the presentation. If you have questions, do not hesitate to contact the chamber or adesso directly. We are very grateful for you attending the webinar today and showing interest in the topic. It's a very new, modern, interesting topic, and I'm glad I also had the possibility to learn something about it. So thank you very much all again, and I wish you a pleasant and sunny day.
Thank you.
Thank you for the participation.
Bye.
Thank you. Bye.